Hello everybody. Today from integration chapter exercise 15.3 we will solve this maths. Question 5. A curve is such that dy by dx equals to k first bracket 2x minus 3 to the power whole power 3 where k is a constant. The gradient of the normal to the curve at the point 2, 2 is minus 1 by a. Find the equation of the curve. We have to find the equation of the curve. Here I want to show you the gradient of tangent is like this, where touch specific point, like the 2 by 2, 2 point, gradient of tangent is this, and gradient of the normal line is this. Perpendicular with this tangent. The normal always make perpendicular with the tangent. And one thing we have to remember, gradient of normal multiply gradient of tangent is equals to minus 1. Now, try to solve this solution. At any point, gradient of gradient of tangent multiply gradient of normal equals to minus 1. If we product the gradient of tangent with the gradient of normal, it must be equals to minus 1. So at this coordinate 2 to coordinate 2 to point, so we have to put this 2 to this is the gradient at this point. Curve gradient and tangent gradient is same. At this point, curve gradient is dy by dx equals to this, and so this is also the gradient of tangent. So we have to write the gradient of tangent k into 2 multiply 2 minus 3 to the power 3 multiply gradient of normal at this point is minus 1 by a equals to minus 1. Very important. Gradient of tangent multiply gradient of normal equals to minus 1. So k 2 to the 4 minus 3 to the power 3 multiply minus 1 by 8 equals to minus 1. So we'll get here minus k by 8 equals to minus 1. So this minus that minus cancel. So k equals to 8. So now what is the gradient of this curve? Now dy by dx equals to k value 8. So 2x minus 3 to the power 3. Now if we want to find out the curve, we have to integrate this. After integration, we will get here y equals to 8. This is 2x minus 3 to the power 3 plus 1. Here also 3 plus 1. And coefficient of x is 2, so you have to write here 2 and plus c. So finally we get here y equals to, here it is 8, below side 2 into 4. So upper side 2x minus 3 to the power 4 plus c. Now if we cancel 8, below side 8, we will get finally y equals to 2x minus 3 to the power 4 plus c. So this is equation 1. This is the equation of this curve. This curve passes through this point. So put this 2 point in this curve in equation 1. So what will you get? Y value is 2 here. Y value 2. 2 into 2 minus 3 to the power 4 plus c. So finally we get 2 to the 4 minus 3, 1. 1 power 4 is 1 plus c. So c value we will get here 1. Now finally we want to find out the equation of this curve. So put c equals to 1 in equation 1. Put c equals to 1 in equation 1. So we'll get the equation of this curve, y equals to 2x minus 2 to the power 4 plus 1. So this is the equation of this curve. Okay. Question number 6. A curve is such that dy by dx equals to 2, first bracket kx minus 1 to the power 5, where k is a constant. Given that the curve passes through the points 0, 1 and 1, 8, find the equation of the curve. So at first we will integrate dy by dx. So dy by dx here to kx minus 1 to the power 5. So if we integrate, we will get here y equals to 2 kx minus 1 to the power 5 plus 1 by 5 plus 1 into k plus c. So we'll get here y equals to, here it will be 6k, upper side 2 kx minus 1 to the power 5 plus 1. That means 5 plus 1 means 6 here plus c. Again, we try to write the formula here. Integration ax plus b to the power n equals to ax plus b to the power n plus 1 by n plus 1 into a plus c. This is the formula for integration of this type of term. Okay. Now, this 2 and this 6 cancel. We will get here y equals to kx minus 1 to the power 6, 3k plus c. This is equation 1. Now, this curve passes through 0, 1 and 1, 8. So at first we have to put 0, 1 in this equation 1. Curve passes at 0, 1. So in a state of x, we have to put 0. In a state of y, you have to put 1 in 1, equation 1. So 1 equals to k into 0 minus 1 to the power 6 at 3k plus c. So we'll get here 1 equals to 1 by 3k plus c. Therefore, c equals to 1 minus 1 by 3k. Now put c equals to 1 minus 1 by 3k in equation 1. So what will you get? We will get here y equals to kx minus 1 to the power 6, below side 3k plus 1 minus 1 by 3k. Mention this equation as equation 2. Equation 2 passes through like 1, 8. It's also pass 0, 1 and also 1, 8. So 1, 8. So in equation 2, we have to put in a state of y a and in a state of x 1. So finally we get k into 1 minus 1 to the power 6 and below side 3k plus if we also this part, we'll get here 3k minus 1. So finally we'll get here 3k k minus 1 to the power 6 plus 3k minus 1. Here it will be 8. Now if we simplify, we will get here 24k equals to k minus 1 to the power 6 plus 3k minus 1. So if we rearrange these, we will get finally k minus 1 to the power 6 minus 21k plus 1 equals to 0. Okay. Now, Now let fk, think this is the equation of this is the function of k. Fk equals to k minus 1 to the power 6 minus 21k plus 1 equals to 0. Instead of k, we try to put some value which give the remainder 0. That one will be the root of k. So if we put here, instead of k3, we'll get here 3 minus 1 to the power 6 minus 21 into 3 plus 1. So it will be 64 minus 64. So remainder is 0. So we can say k equals to 3. Now, put k equals to 3 in equation 2. So our equation of this curve is y equals to 3x minus 1 to the power 6, below side 3 into 3. Okay, here also it will be 9 minus 1. So finally we get here 9 here. So 3x minus 1 to the power 6 plus 8. Okay, finally the answer will be, if we want to write the answer here, so y equals to 3x minus 1 to the power 6 plus 8 divided by 9. This is the equation of the curve. This is the equation of the curve. So I think everybody understand this maths. This is little bit tricky maths. We have to find out the root of k from here, taking fk as a k function. So if you put here k value 3, we'll get remainder 0. So k equals to 3 will be the factor, roots of this function. K equals to 3 is the roots of this function. So we'll put k equals to 3 in the equation 2, then we get the equation of the curve. So thank you everybody for watching. Thank you all.